the Birdman, and it's my honor to be a part of today's celebration of excellence in engineering. Each year, the Engineers Council recognizes the most distinguished men and women who exhibit superior professional qualities and have earned top reputations for their engineering accomplishments and leadership. We're all here to honor these individuals and organizations. But let us first begin our program with the national anthem, performed by Catherine Boynton, a talented senior from Oxbridge Academy. Catherine?
Thank you so much for having me. Oh, say, can you see by the dawn's early light what so proudly we hailed at the twilight's last gleaming, whose broad stripes and bright stars through the perilous fight o'er the ramparts we watched were so gallantly streaming, and the rockets' red glare, the bombs bursting in air, gave proof through the night that our flag was still there. Oh, say, does that star-spangled banner yet wave o'er the land of the free and the home of the brave?
Thank you, Catherine, for the wonderful performance. Catherine Boynton.
Thank you.
The aviation, aerospace, and engineering industry has a legendary presence here in Palm Beach County. And as this county's official economic development organization, the Business Development Board recognizes this industry's dynamic impact on our local economy and actively works to recruit and retain companies in this industry. Please help me welcome one of our hosts this evening, the President and CEO of the Business Development Board, Kelly Smallridge.
Thank you, Tim. Well, good afternoon, everyone, and thank you so much for joining us and taking accomplishment. As Tim mentioned, the Business Development Board is honored to partner with the Engineers Council as the host of this 10th annual National Engineers Week in the form of an awards virtual event. The Engineers Council has been hosting a similar banquet in Southern California for close to 70 years. So we're proud to partner with them again here on the East Coast to recognize your outstanding contributions in the fields of engineering, education, and special fields of work and public service. All of you have helped to make Palm Beach County a worldwide recognized leader in the aviation aerospace engineering cluster. In Palm Beach County, this industry includes commercial and private aircraft, advanced high-tech manufacturing, aircraft parts manufacturing and refurbishment, maintenance training, flight schools and universities, rocket systems, helicopters, computer engineering, electrical engineering, and other engineering services. The entire cluster, including supply chain and support services, has over 1,400 companies employing over 20,000 with an average wage of $102,000, about twice the average wage of Palm Beach County. The estimated economic impact of the entire aviation aerospace engineering cluster is over $10 billion. Now, this event would not be possible without our sponsors, so I want to thank our presenting sponsor, Aerojet Rocketdyne. Thank you, Jim Moss, Vice President, Program Execution and Integration, and West Palm Beach Site Manager. you and your entire team. Thank you for your generous support, not only today, but throughout the entire year as a member of the BDB's board. Now let's turn our attention to the screens to see the exciting things Aerojet is accomplishing. Jim, thank you again to Aerojet Rocketdyne and your entire team for your outstanding engineering accomplishments and leadership in our community. I also want to thank another legendary leader in this field and longtime supporter of the Business Development Board and this event, our platinum sponsor, Pratt & Whitney. Thank you to Marianne Cannon, Matt Enox, and Deanna Usadek for your support as our platinum sponsor. Let's take a look at their video. Thank you again to the entire Pratt Whitney team for supporting this event and for the tremendous economic impact you've had on our county dating back to the 1960s. I'd also like to thank the platinum sponsor Lockheed Martin and Sikorsky, a Lockheed Martin company. Let's turn our attention to the screens again for a dynamic example of their innovation.
At Lockheed Martin, we're on a mission. Your mission. Not just the next mission, but the one that's 2 steps ahead. The one that depends on solving problems before they happen. Our mission is to prepare you for the future by engineering advanced capabilities today so that you can protect what matters most. That's why we've not only taken the lead in hypersonics, but we're helping you integrate that technology faster than ever. It's why we're not only developing the laser weapon systems you'll need, but deploying them in the field. It's why we've coded cyber readiness into everything we do. It's why we created Orion, the only spacecraft that can take humans to the moon, Mars, and beyond. Why the next generation fighter is ready to help you protect the generations to come. And why we've already built autonomous technology and artificial intelligence that advance human ability. The multi-domain battle space of the future is already here, and there's no time to waste. No time to play catch-up. New age threats require new age capabilities. And that's why, at Lockheed Martin, our mission is to build the integrated solutions you can depend on. Because the world is depending on you.
Thank you, Dwayne Olson and Mike Falco and the entire team for your support and dedication, not only to the industry, but to today's awards event. We also want to thank our corporate sponsor, Northrop Grumman, for being part of today's program. Let's turn our attention to the screen.
The sky's the limit. You hear it all the time. And though others may think the sky is the limit, at Northrop Grumman, we believe that's limiting. Because when we combine experience with innovation, there are no limits. No limits to what we can do beneath the waves or above the atmosphere. And no limits to what we can achieve or what we can imagine. The sky's the limit? We don't work that way. We work below it, and above it, and in it. In every domain you can imagine. In domains others can only dream of. And when we all work together, that is when we are limitless. Because the truth is, the sky is not the limit. It's just the beginning.
Thank you again to Northrop Grumman. And my final thank you is to our supporting sponsor, Florida Atlantic University. Thank you so much for your support of this industry and for your assistance in preparing the workforce for the jobs that this industry is creating. Now at this time, please help me welcome Aerojet Rocketdyne Senior Director, RL10 Programs, AR West Palm Beach, Mr. George Pruger, to give some sponsor remarks. George?
Thank you, Kelly. Good afternoon. A bit different doing this presentation sitting in the comfort of my office. Missing the social dynamics of in-person gathering, but the show must go on, and we're here this afternoon to honor our brightest and best engineers and educators. Aerojet Rocketdyne is proud to be the presenting sponsor for this afternoon's event, celebrating our local engineers and engineering educators as part of National Engineers Week. The theme of Engineers Week this year is Imagining Tomorrow. Well, it gets easy to imagine tomorrow when we were able to experience the landing of the Mars Perseverance rover on Mars last Friday. It just floored me how minutes after landing, NASA was able to release pictures of the rover on Mars. And then just a few hours later, we got to see pictures of the rover on tethers being lowered from the sky crane safely onto the surface of Mars. The rover might look small in the pictures, but it's bigger and weighs about the same as a Mini Cooper. So imagine that being lowered down from the sky crane. Perseverance is going to do some incredible science, which will help us better understand how to send humans to Mars, survive on Mars, and then return them safely. That is going to be an incredible feat of engineering and science, and that'll be enabled by our dedicated engineering and science educators teaching our next generation of engineers and scientists. Not sure if everyone knows, but engineers here in Palm Beach were part of the team that enabled Perseverance to achieve its Mars landing. The 22,000-pound thrust RL10 liquid hydrogen, liquid oxygen upper stage engine designed and built at Aerojet Rocketdyne's West Palm Beach facility gave Perseverance a final push from Earth to set it upon its journey 7 months ago. And then propulsion systems from Aerojet Rocketdyne's Redmond, Washington facility provided the deceleration and sky crane propulsion for the landing. And now the power system for the rover, which will enable the science, was designed and built at Aerojet Rocketdyne's Los Angeles facility, is enabling power to the rover. Imagine what that knowledge from Perseverance will do to spring mankind forward towards the stars. Today we celebrate the brightest and best individual and team award recipients, future technology leaders, outstanding engineering achievements, quality engineering achievement, distinguished engineering achievements, distinguished engineering projects, and distinguished engineering educators. Congratulations to all. To those that supported our award recipients, spouses, significant others, extended families, these awards recognize your support and sacrifice as well. Thank you for letting them do what they do. And I think it's back to you, Tim.
Yes, thank you so much, George. On the screens, you'll find each award recipient's headshot and company. I'll give a brief description of the work for which they are being recognized this evening. We are going to start with the Outstanding Engineering Achievement Merit Awards. This award recognizes individuals who have achieved significant accomplishments in a particular area of engineering activity in the past year. This year, the Engineers Council has conferred this award on these exceptional individuals. Our first merit award goes to Lee Vo, Aerojet Rocketdyne, Specialist Engineer in Test Operations at the West Palm Beach Rocket Test Facility. This award is in recognition of outstanding controls engineering, expertise, and leadership in the development, setup, and execution of liquid rocket engine propulsion systems testing. Congratulations, Lee. Our next merit award goes to Mark Ricciardo. Mark was the lead designer for the RL-10CX combustion chamber at Aerojet Rocketdyne. He's receiving this award for significant contributions to the technological advancement of the RL-10 product line. Congratulations, Mark. Our next merit award goes to Kyle Landry. Kyle led the engineering efforts for both the RL-10CX low cycle fatigue rig test team and XR911 development engine at Aerojet Rocketdyne. This award is for significant contributions to the success of the RL-10CX test program. Congratulations, Kyle. Our next merit award goes to Priyanka Valletta. Pri has taken on integral roles as chief engineer and project manager for new construction, renovation, and expansion projects at BRPH. This award is for notable work performance, design and technical support, and outstanding professionalism in team collaboration. Congratulations, Pri. Our next merit award recipient is Jose Carlo Francis, electrical engineer staff with Lockheed Martin. He specializes in the design and integration of electronic assemblies in subsea remotely operated vehicles, or ROVs, and autonomous underwater vehicles, AUVs, with technical focus areas in power distribution, interconnects, and propulsion systems. He developed a compact and reliable electrical power switchgear for the subsea industry that included novel concepts for efficiency while maintaining the reliability of the system. Congratulations on this award, Jose. Our next merit award goes to Jesse Twigger, Principal Engineer Systems Architect with Northrop Grumman Aeronautic Systems. This award is in recognition of his technical capabilities and accomplishments with computational electromagnetic modeling, his mentorship of teammates, and his innovative and inquisitive mindset. Congratulations, Jesse. Our next merit award goes to Matthew Ribikoff, Associate Director, Software Engineering with Pratt and Whitney, for outstanding engineering achievement in advanced propulsion controls technologies for future and existing military applications in control system hardware and software. Congratulations, Matthew. Our next merit award goes to Yoel Bugin, Project Engineer, Turbojet Programs with Pratt and Whitney. This award is in recognition of his invaluable support and technical leadership of the Pratt and Whitney Turbojet program, relentless pursuit of technical product integrity, safety, and continuous improvement. Congratulations, Yoel, on your achievement. Our next merit award goes to Mehdi Nimatahali, Structures Flight Test Engineer, Sikorsky, a Lockheed Martin company. Mehdi has supported Sikorsky's CH-53K flight test program as the lead structures flight test engineer in Pax River, Maryland. He coordinated relocation of 6 test aircraft and has led internal and external customer interface for data reports, progress, flight clearance, and technical discovery. Congratulations, Mehdi. Our next merit award goes to John Telgas, 53K lead flight test engineer at Sikorsky, a Lockheed Martin company. John has an extensive wealth of knowledge that he applies to ensure safe and efficient operations at Sikorsky's Development Flight Center. John led the flight test engineering team and helped establish processes still in use today for the CH-53K flight test program. Congratulations, John. Our next merit award goes to Dimitrios Panagoulias, controls software engineer at Pratt and Whitney, for outstanding technical and programmatic leadership in support of MRO facilities for NGPF programs and the development of processes to certify commercial engines at remote sites across the world. Congratulations, Dimitrios. Our next merit award goes to Sing Yi Liu, staff engineer at Pratt and Whitney. She has brought solid engineering knowledge and leadership skills to her role as team lead, resulting in successful completion of targets and a high degree of management and customer satisfaction. Congratulations, Sing Yi. Our next merit award goes to Sade Morris, Aerojet Rocketdyne. She was the lead of a significant anomaly resolution team for resolution of acceptance test fires on the RL-10 program. This recognition is for exceptional leadership of the RL-10 ATP fire investigation. Congratulations, Sade. Our next merit award goes to Matt Bullivant, Aerojet Rocketdyne, for technical leadership of the RL-10CX development program, resulting in significant risk reduction in 2020, leading to engine qualification. Congratulations, Matt. Our next merit award goes to Edric Gonzalez, Belcan, in recognition of leading the Belcan structures team on the PW1500 HPT rotors limits expansion task. With over 12 years of analysis experience, which he uses to help the Belcan team solve complex structures problems and mentors new engineers by teaching them how to perform various types of analyses. Congratulations, Edric. Our next merit award goes to Jennifer Smith, senior engineer with Chen Moore and Associates. Ms. Smith has over 12 years of engineering consulting experience, specializing in civil engineering design and modeling for clients. Her work includes GIS and AutoCAD design, detailed utility improvements work on water and sewer improvement projects. Congratulations, Jennifer. Our next award goes to Dr. Han-Chi Zhuang, professor at Florida Atlantic University, College of Engineering and Computer Science. Recently, Dr. Zhuang and his students developed a machine learning-based model that can successfully predict loop current movement in the Gulf of Mexico. This award is in recognition for renowned research in acoustics, signal processing, machine learning, and their applications. Congratulations, Han-Chi, on your award. Our next merit award goes to Dr. O.G. Marquez, professor at Florida Atlantic University, College of Engineering and Computer Science. Dr. O.G. Marquez shares his engineering knowledge and his passion for lifelong learning with thousands of engineering students worldwide, preparing them for the next steps in their professional lives. This award is in recognition for excellence. Congratulations, OG. Our next merit award goes to Dr. Anish Gawley, President at Smart Structures. Dr. Gawley is well known for championing the development of innovative solutions for smart infrastructure, especially for the life cycle monitoring of infrastructural assets, positively impacting the global infrastructure. Congratulations, Anish. Our next merit award goes to Matthew Rojas, structural engineer at BRPH, creating great innovations in structural engineering to allow space exploration and satellite deployment to remain dominated by the United States. Congratulations, Matthew. Wow, that's great work by all of these extraordinary winners. Congratulations to all of the 2021 Outstanding Engineering Achievement Merit Award winners. We are now going to recognize the Engineers Council Outstanding Engineering Project Achievement Awards, which are awarded to organizations that during the past 3 years have brought to fulfillment engineering projects which, because of their scope or unique character, present distinguished engineering excellence. The Engineers Council has conferred the Outstanding Engineering Project Achievement Award on 7 worthy projects that will be presented today. Our first team recipient of the Outstanding Engineering Project Achievement Award goes to Aerojet Rocketdyne, RL-10CX LCF Rig Test Team. Team lead Kyle Landry, Duncan Harris, Tyler Jennings, Josephine Jackson, Robert Grabowski, Mark Krantz, Thomas Kellum, Peter Keith, Carl Shirey, George Roush, Seth Kegley, Patrick Hayes Jr., Joseph Menon, Jacob Wilson, and Jack Woods. For achieving 65 starts and 8 test setups, demonstrating required 4 times life requirement for the RL-10CX combustion chamber. This campaign demonstrated a total of 65 starts and 8 setups on the RL-10CX chamber, exceeding a 56 cycle goal. To accomplish this cost effectively, the team worked to enable 10 cycles in a single setup. This was the first time that relight tests of a combustor were accomplished on AR-WPB E8's high pressure systems, and the ability to complete 10 cycles in a single setup also exceeded what could be accomplished with an engine. With this accomplishment, the RL-10CX chamber has demonstrated a key operational life capability. The success of this campaign is a direct result of each team member's contribution and dedication. A big congratulations to this team. Our next Outstanding Engineer Project Achievement Award goes to the Lockheed Martin Undersea Systems Autonomous Unmanned Surface Vessel. Team lead Sekar Tangirala, Bailey Witt, Corey Stephen, Blerund Keriki, Troy Yost, Anthony Spinuzza, Marty Giuliano, Corbin Spells, James McDonald, Wyatt Raich, Brian Wagoner, Katie Janney, Peter Giel, and Nate Sibak. Matrix autonomy software developed by Lockheed Martin Sikorsky for optionally piloted rotorcraft has been extended for use on unmanned underwater surface vehicles. In 2020, Lockheed Martin developed and demonstrated an autonomous surface vessel by modifying an 11M RHIB with autopilots and matrix with a successful, fully autonomous mission executed on the first offshore attempt. The autonomous surface vehicle code was run offshore using individual Docker containers for the vehicle control and autonomous control. The containers were supported by two separate operating systems demonstrating a real-time microservices architecture. The project represents a significant milestone in Lockheed Martin's ongoing autonomous systems development. Congratulations to this team for the first successful Lockheed Martin Undersea Systems autonomous surface vessel demonstration conducted in West Palm Beach, Florida. Our next Project Achievement Award goes to the Lockheed Martin Undersea Systems Deep Learning for Autonomous Systems, Lockheed Martin. Team lead Joe Cuscieri, Mike Sokoloff, Nate Sibak. Lockheed Martin has been working on methodologies to improve object recognition in the subsea domain. These methodologies include various traditional machine learning approaches and statistical augmentation combined with the latest in convolutional neural network configurations to create solutions that result in a system capable of processing data with a high probability of detection and classification, along with a very low false alarm rate. These advancements open a new door to what can be achieved in the subsea domain from an autonomy perspective and have shown good performance in land-based domains as well. Congratulations to this team on their hard work. Our next Outstanding Project Award goes to AIML Maritime Vessel Classifier, Northrop Grumman Aeronautic Systems. Team lead Deborah Beatty, Lee Nguyen, David Marcus, Roy Shearing. Target identification is a challenge by itself, but adding automatic target ID utilizing machine learning is a big step forward. Artificial intelligence and machine learning can accelerate the kill chain by shortening the time required to make decisions in tactical scenarios, including automatic identification of potential targets. An AIML maritime vessel classifier using high-range resolution, moving target indicator radar profiles was developed. A variety of machine learning approaches and libraries were investigated. Initial classifier work in supervised learnings was completed using MATLAB classification learner. Specifically, 8 machine learning algorithms and 2 validation techniques were explored. This award is in recognition of the team developing a maritime vessel classifier using machine learning, accelerating the kill chain by shortening the time required to make decisions in tactical scenarios. Congratulations to this team on their ingenuity. Our next Outstanding Project Award goes to Increased TM Bandwidth, Sikorsky, a Lockheed Martin company. Team lead Rod Condon, Arian Torres, John Pandoli, Brad McLaren, Edgar Laraquente, Joe Conlon, Pat McCauley. A group of Sikorsky JMR test team members from the instrumentation, programming, and the telemetry departments on their own volition acted as one team to incorporate esoteric advances in recent data encoding and telemetry techniques to achieve 2 landmark changes to the fields of data acquisition, telemetry, and processing. The first concept improved cost, schedule, and safety for flight test operations. The second transformational effort was to advance data rates, potential for two-way communications, modular data systems, and reduction in wiring harness complexity will benefit JMR and all future programs. Congratulations to this team on their dedication and hard work. Our next outstanding project award goes to PWNSMS, Real-Time Software and Training Development Team, Pratt and Whitney. Team lead Kailani Redding, Parker Eason, Ian Agus, Mark Davidson, Ted Dreger, Karen Kwolek, Sebastian Martinez, Allison Nicholas, Cliff Polchik, Ron Whidden, Darren Wind, Glenn Schroeder, Terry Renshaw. The Pratt Whitney Legacy NSMS, Non-Intrusive Stress Measurement System, real-time software was rewritten in a modern software package compatible with Windows OS and included added and enhanced capabilities such as real-time Campbell diagram for integral stress monitoring to satisfy customer data requirements. Congratulations to the Pratt and Whitney team. The final Project Achievement Award that we will present goes to the BRPH team that designed the Fox Factory. Team members Marty Watts, Jason Dunn, Ray Rarick, John Stevenson. The Fox Factory is a headquarters relocation across country designed to elevate the brand of a national specialty vehicle manufacturer. The new 30,000 square foot corporate headquarters and manufacturing floor center is designed to align aesthetics and function with the core corporate values of the company. Located in Gainesville, Georgia, the new manufacturing center provides tooling, CNC machining, lathing, clean rooms, shipping, receiving, distribution, and all the processes of a self-sustaining factory center. Congratulations to the BRPH team on this amazing facility. Let's give all of those Project Achievement Award winners a huge round of applause. That's some great stuff. All right. Pratt and Whitney congratulates all Engineers Council 2021 award recipients. Go beyond with Pratt and Whitney dependable engines. Without the next generation, there's no next generation innovation. Lockheed Martin is proud to support organizations like the Engineers Council that inspire young people to study science, technology, engineering, and math. At Lockheed Martin, your mission is ours. Corporate sponsor Northrop Grumman congratulates all Engineers Council 2021 award recipients. At Northrop Grumman, we're defining possible. Supporting sponsor, Florida Atlantic University College of Engineering and Computer Science congratulates all 2021 Engineers Council honorees. It is now my pleasure to introduce our keynote speaker for the evening. We are honored to have Dr. Michael Winter with us today. He is the Senior Fellow for Advanced Technology at Pratt & Whitney, where he leads the company's technology portfolio internally and represents it externally. In over 30 years with Heritage UTC, Michael has had several executive and senior fellow leadership roles at United Technologies Corporate, Pratt & Whitney, and the Corporate Research Center. He's made contributions working with fuel cells, lasers, rotorcraft, and combustion and propulsion systems. Dr. Winter holds Doctor of Philosophy, Master of Science, and Master of Philosophy degrees from Yale University, and a Bachelor of Science degree in Mechanical Engineering from Drexel University. He is the author of more than 40 patents and more than 50 beautiful published technical articles. Dr. Winter is on the advisory board of the engineering school at Embry-Riddle Aeronautic University. He has served on the National Research Council Board of Assessment of the National Academies an associate fellow at the American Institute of Aeronautics and Astronautics, AIAA, and as a chairman of the Aerospace Industry Association, AIA, Environmental Committee and Technical Operations Council. Please help me welcome Michael Winter, our keynote speaker.
Thank you. On behalf of Pratt & Whitney and Raytheon Technologies, we appreciate the opportunity to address you tonight. And we'd also like to extend our congratulations to all of the award winners this evening. Please go to the next slide. As we talk about sustainable aviation, I'd like to frame it in the context of geosocial and global situation. Of the 7.7 billion people on the face of the planet, starting in around 2016, more than half moved to cities. And what does that mean? As people moved to these mega cities, we saw increase in economic activity because people interacted with each other more. That's just the money multiplier effect. And that means the rise of the middle class. And so as people were in these cities, they had more disposable income and they start to travel between the cities. And we see the rise in air travel. Up until now, fewer than 20% of the population of planet Earth have ever set foot on an airplane. And we expect that to continue to grow. So if you go to the next slide, please. We also have the downside effects of this. And that is represented both in terms of course, the current pandemic, as people are interacting with each other more frequently, particularly in urban settings. We had very quick spread. And then with the transportation between locations, we also had the spread of disease between locations, and the result was the pandemic. And what we're going to talk about this evening is climate. And the reason is that we're very much looking forward to the pandemic being behind us with the rollout of vaccines. And as we look to the future, we recognize that global climate change is going to be before us for long term, and we need to take definitive actions. When you think about a propulsion system, an airplane and its engines, less than 10% of an airplane and its engines CO2 is produced in the actual producing of the airplane, the first time the airplane gets to the gate, from when you take the metal out of the ground until that first flight. And 90% of the CO2 happens from the burning of the fuel in flight. And in fact, for an engine, it's less than 2% in the production, 98% happens in flight. And so we as a company are really focused on this. Please go to the next slide. And so when you think about the impact and emissions of an airplane in the airspace at ground level, we focus on oxides of nitrogen, ozone, particulates, and of course noise. And those are currently regulated to a high degree. And the new focus is on what happens as flight accrues in the troposphere. Emissions of carbon dioxide, oxides of nitrogen, and water. It turns out that in 2019, the commercial fleet burned just shy of 100 billion gallons of fuel. 100 billion gallons, it's a huge amount. And so we need to understand this and do everything in our power to minimize those emissions. We also recognize that water by itself can also, as well as oxides of nitrogen, can contribute to global warming. Water in particular, in the formation of contrails, the clouds you see behind an airplane, they reflect sunlight back up to the sky during the day, but at night they trap the longer wavelength between the ground and the sky, and that has a shorter term but fairly significant contribution. Next slide, please. Now let's talk about a gas turbine engine. A gas turbine engine is the most sophisticated mass-produced device known to humankind. With over 40,000 parts, these parts are moving at tens of thousands of RPM, and some of the parts are coming literally within a hair's breadth of the parts that are not moving. The air comes in and it's compressed. And of course, as you compress gas, what happens? It gets hot. Think of your bicycle pump. And at the back of the compressor, the temperature is so hot, it's hot enough to melt rocks, Typically, rocks melt around 1210 degrees Fahrenheit. That's twice the temperature that your oven gets to at self-cleaning mode. And then what do? We dump in fuel and we light it on fire. And so it gets even hotter. And then at the back of the combustor, as the hot gases enter the turbine, it's so hot, it's hotter than the melting point of most of the metals surrounding it. Maybe don't think about that next time you're on an airplane. The turbine blades are usually made of a single crystal of metal about the size of my hand. And that, think of that in terms of like rock candy you made as a kid, single crystal. And in it are drilled usually thousands of little holes, drilled oftentimes with laser beams, so that air that's cooling the inside of the blade comes out effusively. Think of like an air hockey table. So the hot gas can never, ever touch the surface of the metal. And all this is going on as it's spinning at tens of thousands of RPM. And of course, the pull load on a blade due to the centrifugal force is equal to the weight of an entire fighter aircraft. Just so you need to hold on to it under these extreme conditions. So why don't we go to the next slide? Now, on this slide, you see two airplanes, the Boeing 707 and the Boeing 787. These airplanes were introduced a little more than 50 years apart. Did they look any different? Not really. They're both tubes and wings. They both have engines hanging under the wing. Yes, one has 4 and one has 2. That's actually a testament to the reliability of our modern engines today, which are 6 or 7 orders of magnitude more reliable. And that's why they can go over the ocean for extended operations with 2 engines. But it turns out that airplanes and engines have been getting more efficient by about 1 to 1.5% year over year over year. And in those 50 years, the amount of fuel burn per seat, per passenger seat mile, has gone down by 70%. Now, recently at Pratt & Whitney, we introduced a new concept. It was a disruptive technology called the gear turbofan. This engine is 16% more efficient than anything flying previously. It has 50% of the oxides of nitrogen of those prior engines, and it has a 77% lower noise footprint, all based on a new engine architecture and new technology insertions. 16% fuel efficiency improvement is a really significant amount of CO2. Let's go to the next slide. And let me put that in context for you. Consider a tree in the forest. The sun is shining, and this, of course, the trees are doing photosynthesis. They're pulling CO2 out of the atmosphere. And so each airplane with its 2 engines are the equivalent of 3,600 tons of CO2 not produced. That's the equivalent of 900,000 trees per airplane per year. 900,000 trees. And we've sold enough engines to populate more than 5,000 airplanes already. This airplane and engines entered the fleet in 2016. So we really have a huge runway ahead of us on that. Now, let's go to the next slide, and we'll talk about some of the new technologies that are coming into play for introducing even greater efficiency. And we see a very significant amount of introduction of these new technologies. Number 1, sustainable aviation fuels, or SAF. These are fuels made from biological materials, electric, both fully electric and hybrid electric. We see a lot in the press about hydrogen and new thermodynamic cycles. And this is going on all over the world. There's huge investments, especially by governments, into these technologies. And we're also seeing a lot of new entrants, a lot of new small companies entering the market. So on the next slide, we'll talk briefly about each of these technologies, just so everybody has a taste of what they're about. In a traditional engine, right, you pour in fuel, you burn it, and you turn it into shaft energy that turns a propulsor in the front. With sustainable aviation fuel, these are fuels that are drop-in replacement. There are 7, coming up on 8 drop-in fuels made from sustainable sources that can be used in the fleet today. They are used in the fleet today. And you'll see these being announced by many, many airlines are starting to ramp up on their use. Currently, they're a lot more expensive, about 2.5 times the price of traditional jet fuel. Fully electric is what happens when you run on batteries. Hybrid electric is a combination. Think of your hybrid electric vehicle. You have a combination of both electrical, maybe from a battery and a motor combined with fuel. Again, hydrogen, you could put hydrogen in an engine. We love hydrogen. Our engines are agnostic, we'll burn anything. So hydrogen would work just fine, but you probably want to take advantage of some of the storage of hydrogen. Hydrogen doesn't store very well. It has about 3 times the amount of energy per unit mass, but it's about 4 times the volume. So you need to liquefy it and you want to recover a lot of that energy. It turns out that in the 1950s in West Palm Beach, we ran engines that ran on hydrogen using these types of advanced expander cycles. And then there are other things that we can do to the traditional jet engine to continue to improve its efficiency. So let's go to the next slide and we'll take a look at some of these. And on this slide, I show you the thermal efficiency. This is what happens in the core of the engine with the compressing the gas, the burning and the expansion of the gas happens in the core. And this is a history over the last 83 years since the dawn of the jet age. And there's a line there that shows the theoretical line. Couple observations of all the engines up till now, that number one, we've been tracking at about 70% of the theoretical efficiency. And that makes sense relative to how efficient our engines are today. Number two, we're only halfway there. That is, we've only come in 83 years halfway to what the theoretical limit of the thermal efficiency of the Brayton thermodynamic cycle is. So there's a lot of runway. Now, the concern is that on the bottom of this chart, you'll see there's some temperatures, and those temperatures get really, really hot. Okay, so let's go to the next slide. And on this, so we talked about what we did with the geared turbofan. That really focused on the blue line. That was propulsive efficiency. We just talked about thermal efficiency. As you start to do these things, what happens is, especially in the thermal efficiency, the size of the core of the engine gets smaller and smaller and smaller. And it happens in a very nonlinear way. You see the green line. Well, it turns out there's some new technologies like additive manufacturing and some others that let us take advantage of these technologies. So we're really excited about that. Well, let's go to the next slide. And on the first panel, you can see that turboprops, they tend to be only about 35% efficiency. And a modern airliner at cruise about 50 to 55% efficient. That's turns out that's about 15% less CO2 than the world's electric grid today. Next slide, click it again. And what you'll see is what is the energy density of jet fuel on a volume and mass basis. And click it one more time. And you'll see compared to that are all the battery technologies that are known. These are at the cell level, not at the package level. So you still have to put it in a box. The box has to be fireproof. You need current management. You need thermal management. That all adds mass. Now, I've cheated a little bit because you'll note that the axes are different in the right and the middle panel. So click it one more time and I'll put it all on the same graph. And what you see is that batteries are almost 2 orders of magnitude lower energy density than jet fuel today. Interesting factoid, 2 other species we share planet Earth with that fly are very close to the jet fuel dot on the chart. Jet fuel is about 45 megajoules per kilogram. Goose fat is 32 megajoules per kilogram, and honey is 12 megajoules per kilogram. So something else to think about. Next slide. It turns out that when you think about using electric and hybrid electric, the technology exists today to do these air flying taxis, urban air mobility. That's about 1 megawatt. And if I go all the way to the right-hand side, when A320 is roaring down the runway, 30,000 pounds thrust, that's about 18 megawatts. If I had that same megawatt, I could use all that power electronics in all spaces, and I can make a hybrid electric, and that has value in the market even today. And if you go to the next slide, it comes down to systems engineering. How do I configure my system? Either all electric, series hybrid electric, or parallel hybrid electric. And each of these can be used to take advantage of the opportunities in different market spaces. On the next slide, we look at the range of things the industry has committed to by 2050 being at 50% of 2005 levels of CO2. And there are a number of things that the industry is doing. The blue is the 1.5% you see year over year. Operations is more about how the aircraft routing is done for direct routing of aircraft. And with our Collins Aerospace sister division that makes navigation systems combined with Raytheon Intelligence Space that does radar navigation for weather, we can put that together for another 1.5% efficiency. Infrastructure happens at the airport. And then you see biofuels. On the next slide, we'll look at what biofuels are. And this is using biological materials and bringing them to bear, essentially processing them. These could be waste from your dump, it could be sewage waste, or it could be forest waste, and processing it into jet fuel. And today we see many projects that are ramping up the production of these types of fuels. And on the next slide, actually click it twice. So we'll go to the second to last slide. And we'll think about what is the future of aviation. We believe the future is bright. We do see a number of supersonic transports back in commercial coming of age, and there are a number of companies of record that are developing these. We see commercial transportation becoming ever more quiet and ever more efficient, and we will see the advent of urban air mobility. We're already starting to see it crop up in a number of places around the world. And I'll end with the last slide. I like to end on a provocative note. And on the last slide, in the left-hand panel is a patent, a US patent that was granted in 1842 to Stringfellow and Henson for a steam-powered air carriage. And in 1882, the panel on the right was published, I believe, in Le Monde in France. And it was a series on what life will be like in the year 2000. And you see the people coming home from the opera. That's what the caption talks about, coming home from the opera, getting into their flying taxis. So I thank you for your attentions, and I'll turn it over back to the event.
That's right. Thank you very much, Michael. We enjoyed that immensely. We do want to make sure that Aerojet Rocketdyne congratulates all Engineers Council 2021 award recipients. At Aerojet Rocketdyne, we are mission ready, investing in and advancing cutting edge technologies. Now, it is my honor to recognize the Distinguished Future Technology Leader Award recipients. With this award, the Engineers Council recognizes early career professionals who have achieved significant accomplishments in a particular area of engineering activity within the first 5 years of their career. Today, we will honor those individuals. Our first recipient of the Future Technology Leader Award is Mason Anthony, Materials and Process Engineer at Aerojet Rocketdyne, for technical excellence in advancing cryogenic upper stage propulsion technologies. Mason has demonstrated technical excellence, outstanding leadership, and exemplary teamwork in support of advancing RL10 product line technology. His in-depth and intimate knowledge of complex manufacturing processes has been instrumental in their successful implementation and qualification for upper stage propulsion. Congratulations, Mason. Our next recipient of the Future Technology Leader Award is Fallon Mans of Aerojet Rocketdyne. Fallon has successfully taken her project from the early stages of design through a major design change and has successfully led her team to completing the necessary design reviews, presenting in front of an AR review board as well as the U.S. Air Force customer. Just recently, the first demonstrator nozzle was successfully hot fire tested on an RL10 development engine, resulting in a key improvement of the nozzle's technical maturity level. This award is for outstanding technical and project team leadership in the development of a new lightweight high temperature CSIC composite nozzle for the next generation RL10CX engine. Congratulations, Fallon. Our next recipient of the Future Technology Leader Award is Jake Bernhardt of Aerojet Rocketdyne. Jake was a key member of the RL10CX team during the successful completion of both the combustion chamber critical design review as well as the engine system critical design review. Jake is an active participant in multiple integrated product teams and supports the RL10 production program in evaluating hard changes and clearing flight hardware for use. This award is for outstanding contributions to the RL10 and RL10CX program success. Congratulations, Jake. Our next recipient of the Future Technology Leader Award is Joseph Peter Barillo, FCS HQ Flight Test Engineer at Sikorsky, a Lockheed Martin company. Joe became the primary FTE supporting the flight control system tests for the Combat Rescue Helicopter program. Often, Joe flew on board in support of tests to be apprised of the results. Joe successfully supported CRH test conduct as the primary AFCS flight test engineer. He completed a complex test report in a short amount of time to support aircraft deliveries. Congratulations, Joe. Our next recipient of the Future Technology Leader Award is Melissa Eziga Echevarria, engineer, control systems at Belcan. Melissa is recognized for her excellence in project engineering. Her exemplary leadership skills, combined with her technical knowledge and abilities, will afford her great opportunities in the future. Congratulations, Melissa. Our next recipient of the Future Technology Leader Award is Dr. Amjad S. Al-Mansour, Research Materials Engineer at NASA Glenn Research Center, for outstanding technical contributions to aerospace materials and technologies and demonstrated commitment to outreach efforts, mentoring, support, and encouragement to next generation of STEM leaders. We say, congratulations, Amjad. Our next recipient of the Future Technology Leader Award is Marley Trier. Her experience includes stormwater modeling, water treatment facilities, water distribution, drainage, grading, paving, design reports, water and stormwater master planning, plans and specifications production, and construction inspection and testing. For the past 9 years, she has worked with the organization Engineers Without Borders, assisting in the design and construction of a concrete vehicular bridge and cable suspended pedestrian bridge for communities in rural parts of Guatemala. Congratulations, Marley, and congratulations to all of these exceptional recipients of the Distinguished Future Technology Leader Award. The STEM Educator Award is a science, technology, engineering, and math educator award. And with this award, the Engineers Council recognizes individuals who are outstanding in professional qualities and have a top reputation for engineering accomplishments and leadership. Our STEM Educator Award recipient is Dr. Mike Kim, professor at Florida Atlantic University, College of Engineering and Computer Science. Dr. Mike is a dedicated researcher and educator who is passionate for STEM education. He creates an engaging and supportive learning environment and has made remarkable impacts in society. Congratulations, Mike. At this time, I'd like to welcome the co-chairman of the Business Development Board's Aviation Aerospace Engineering Task Force, Mr. Chris Vigil, Senior Vice President and principal of BRPH, to say a few remarks this evening. Chris?
Thank you. Thank you, Tim. Good evening. Aerojet Rocketdyne has nominated this year's recipient of the Quality Engineering of the Year Award. This award recognizes a singular individual who has achieved significant career accomplishments in the field of quality engineering within the engineering industry and for leadership in mentoring and training quality management audit systems. Our Quality Engineer of the Year award goes to Mal Prevet, Aerojet Rocketdyne. He developed and delivered a certification process that has produced an outstanding material review board comprised of highly competent subject matter experts. In recognition for broad technical acumen and dedication to the profession of quality engineering evidenced in the principles of quality assurance of the RL-10 engine product lifecycle. Mal has been steadfast leader in the RL-10 material review process for many years. Congratulations on receiving this award, Mal. I, like the rest of you, would love to hand these awards and personally shake your hands, but these are different times that will certainly change, and I firmly believe that in every challenge found throughout history, it's the engineers that make the most significant impact to change the future. We make a difference. We are the difference makers. So it's my honor to present the Distinguished Engineering Achievement Awards to our difference makers. With this award, the Engineers Council recognizes individuals who are outstanding in professional qualities and have a top reputation for engineering accomplishments and leadership. Our first Distinguished Engineering Achievement Award goes to John Evans, Aerojet Rocketdyne, for significant contributions to the mission and program success of the RL-10 product line. John Evans has shown exemplary leadership of the RL-10 product line for the past 3 years through a significant growth in the production as well as integration of the RL-10 engine into additional customer vehicles. He consistently met program and corporate financial goals. He was able to do this through effective risk management of the product development and integration while maintaining the heritage product reliability. John's leadership has set the RL-10 product line on path for continued success and growth. Congratulations, John. Our next recipient of the Distinguished Engineering Achievement Awards is James Gill, Staff Engineer, Software Computer Engineering at Pratt & Whitney. Jim has been steadfast in providing solutions to Pratt & Whitney products for many years. He is a key asset in his ability to support both legacy and state-of-the-art systems and in bridging the gap in between. For outstanding engineering achievement in advanced propulsion controls technologies for future and existing military applications in control systems hardware and software, we congratulate Jim. Well done. Thank you. Our next recipient of the Distinguished Engineering Achievement Award is Jose Gomez. Jose is a geotechnical chief engineer at Intertech PSI as an expert consultant around the world. He has extensive experience in a wide range of geotechnical and civil engineering consultant services for several hundred projects since 1980, including hydroelectric, irrigation, transportation, and port projects as far off as Colombia. He's very familiar with a variety of geological and residual soils in Central and South America. His projects face excavations and slope stability analysis, dam design, stabilization measurements, shallow and deep foundation designs, dewatering systems, and bulkhead designs, including forensic and value engineering. Wow. Congratulations, Jose. What a great career. Our final recipient of Distinguished Engineering Achievement Award is Dr. Michael Popp, Program Manager, the RL-10CX Engine Development at Aerojet Rocketdyne. He is receiving this award for exceptional technical and programmatic contributions and achievement of the engineering profession in the field of liquid rocket engine propulsion. Across geographic and language borders in the industry and academia, Dr. Pop is considered a true leader in the world of aerospace exploration. Congratulations, Dr. Pop. We have 4 recipients of the Distinguished Engineering Educator Award, which honors individuals who are outstanding in the profession and have a top reputation for engineering education, mentorship, and leadership. No matter how many years past college you are, we all remember those professors that wonderfully impacted our future. These next 4 recipients are positively affecting the future of our next generation. Our first Distinguished Engineering Educator Award recipient is Ira Rosenthal, professor, faculty developer at Palm Beach State College. Mrs. Rosenthal is a highly respected mathematics professor who teaches, inspires, guides, and advises her students toward higher mathematics, intelligence, and towards careers in engineering. Congratulations, Ira, on this recognition. Our next Distinguished Engineering Educator Award recipient is Kevin R. Mackey, Associate Professor, Structural Engineering Department of Civil, Environmental, and Construction Engineering at the University of Central Florida. He is an active member of numerous national technical committees within ASCE's Structural Engineering Institute. He oversees the activities of numerous other technical committee chairs and journal associate editors. Prior to this, he served as chair for the National Earthquake Engineering Committee. Help me congratulate Kevin for his wonderful contributions in education. Our next Distinguished Engineering Educator Award recipient is Dr. Ramesh T. Gavarapu, professor at Florida Atlantic University, College of Engineering and Computer Science. Affectionately known as Dr. T, he is being recognized for outstanding sustained contributions to water, environmental, and climate systems, modeling research and innovation, and excellence in engineering education. Congratulations, Dr. T, on receiving this award. Our final Distinguished Engineering Educator Award recipient is Dr. Evangelos Kaisar, professor and director at Florida Atlantic University, College of Engineering and Computer Science. Dr. Kaisar is a pioneering researcher in the areas of transportation operations. As an educator and practitioner, he has continued advocating the importance of bringing engineering practice to classroom education. Congratulations, Evangelos. We certainly appreciate all the dedication work that you do. Congratulations to all the recipients of the 2021 National Engineering Week Awards, and let's give you all a big round of applause. Well, that concludes our evening. I want to thank you on behalf of the Business Development Board, the National Engineers Council, my company, BRPH, for attending this celebration of engineering excellence. As we adjourn, may we all stay safe and healthy. In keeping with this year's theme of Engineers Week, let us keep imagining tomorrow. Take care, everyone. Be safe and have a good night.